What does the pericardium do? The pericardium is an important structure around the heart. It keeps the heart fixed in space, mostly because this covering around the heart is attached to the diaphragm. It's also attached to the great vessels and the sternum overlying the heart. It keeps the heart constrained when it comes to potentially overfilling. The fibrous pericardium is very tough and limits heart movement. Because of the serous layer around the heart, there is effective lubrication as the heart beats, avoiding friction. In some ways, the pericardium also protects the heart from outside infections. Blood supply to the heart. There are a couple of things to think about when learning about the blood supply to the heart. There are the blood vessels that enter and leave the heart in obvious ways. Certainly you can say that the entirety of your blood supply enters and leaves your heart frequently. In fact, with a normal cardiac output, you shuttle your entire blood supply completely around the loop every single minute. But this isn't the same thing as when we talk about the blood supply to the heart itself, which comes only from the coronary arteries that surround the organ. As we talk about blood supply, we'll do it in order from just before entering the heart to just after leaving it. As you know now, the process starts when the vessels enter the right atrium through two large veins known as the inferior and superior vena cava. The inferior vena cava takes blood from below the diaphragm back to the heart to be pumped into the lungs. Far below this vein are the two common iliac veins in the pelvis, one for draining blood from each leg. There is very little pressure in the venous system, so the veins have valves that help prevent blood from pooling in your feet every time you stand up. Movement of the leg muscles and thin muscles around the veins help squeeze blood upward toward the heart. The superior vena cava takes blood from the upper body except the heart itself and sends it to the right atrium. The brachiocephalic veins come together in the thoracic region to drain both sides of the upper body. It comes down along the right side of the chest before entering the heart. You can see in this image that several jugular veins drain the facial and brain areas. The next main vessel when it comes to blood flowing through the heart is the pulmonary trunk. It comes off the heart as a single vessel, drawing blood out of the right ventricle to each lung. The pulmonary trunk itself is short, quickly separating into the left and right pulmonary arteries. These arteries have many branches that get progressively smaller in diameter until they become capillaries. It's these tiny capillaries that interface in the lungs to collect oxygen and give off carbon dioxide. This process of gas diffusion in the lungs is largely a matter of physics. The concentration of oxygen gas in the lungs, air sacs or alveoli, is higher than the concentration of this gas in the deoxygenated capillaries. This naturally means that oxygen will flow from high concentration areas to areas of low concentration. The reverse is true for carbon dioxide. Because of cell metabolism, which gives off CO2 as a result, the concentration of CO2 in the veins is higher than in the alveoli. This gas therefore diffuses from the inside of the capillaries into the alveoli proper. This is what gas exchange looks like in these alveoli. The four major pulmonary veins, two on each side, gather all the blood from the lungs, now oxygenated, drawing it into the left atrium. They do not come together but instead have separate entry points into the left atrium as shown. This leaves us with the aorta, which is ready to receive oxygenated blood from the left ventricle so it can go out to the periphery, the systemic circulation, again. Blood is essentially ejected upward for a few inches until it reaches the aortic arch, a true arch that makes a 180-degree turn in order to send blood down to the lower extremities. This arch has its own branches that send blood to the head and neck as well as both upper arms. These major branches look like this.